Hello College Algebra and welcome to 6.3. We are on matrix operations. I think you'll like this section. It's a lot of fun. And we're going to do a few applications with them on how to use them. So make sure you have 6.3 out and you're ready to go to your notes. Alright, when we are doing matrix operations here, let's get back up. Let's see if we can get this to move where we need it to move, huh? There we go. Okay, we're going to use matrix notation, how it works. We're going to check when matrices are equal. We're going to add and subtract, scalar multiplication, kind of like what you did in geometry. Solve matrix equations. We're going to multiply them. This one here is the most difficult, so make sure you're paying good attention there and taking great notes. All right, the first thing to look at is matrix notation. We've already talked about this. A is the name of the matrix. It's a 3 by 2 because we have 3 rows and 2 columns. That's what you're looking at. Okay, if I ask you for A12, I'm asking you what is in row 1, column 2. So you go row 1, column 2, and you get -2. 3-1 is row 1, column 1. Row 3, column 1 is 1. So it's just, can you read? Do you know where I'm asking you to look? All right, pause and do yours. Okay, B is a 2 by 3 matrix. 2 rows, 3 columns. 2, 3. So row 2, column 3 is 3. And 1, 2 is row 1, column 2 is 9. I hope you did well on that. Okay, let's continue down. So the next section is we have to define a matrix, need to know if they're equal. Equal means they are the exact same size and every element is identical. So when you go through here, these are the exact same size. This is a 2 by 2 and this is a 2 by 2. That's the first step. The next step is everything matches. First to first, the same. If you look, 5 is the same as 5, same location. Second row, first column, identical. And second row, second column, identical. So they are equal matrices. These two are not equal right here. Even though they have the exact same elements, they are not in the same place. So this here is a 2 by 3 and this is a 3 by 2. They are not identical, therefore they cannot be equal. Down here, we have to do a few equations with them all. So I have a 2 by 2 and a 2 by 2, so we're off to the right start. Here we have variables we can actually solve for. So this means x equals 1. Done. I'm checking here, does 5 equal 5? The answer is yes, we can cross him off. Does -1 equal -1? True, we can cross him off. 3 equals y plus 2 is an equation you solve for y by just subtracting 2, so y equals 1. And that's done. Okay, pause and do yours. Is this equal? The answer is no. It is a 2 by 3 and a 2 by 3, which is true, but element 1, so row 1, column 1, and row 1, column 1 here, this one equals 1, this one equals 0, therefore they are not the same. This element does not equal this element. They are not equal matrices. All right, we're going to add and subtract. In order to add and subtract, they have to be the exact same size. Then we just do element to element. So we look here, this is a 2 by 2, and this is a 2 by 2. So we can add or subtract them. This time, if you look, we want to subtract. So we are subtracting each element. So to do this, let's write it out for you. We are taking 0 minus -4. Your second element, you're taking 10 minus 6. Okay, now we're going down to the next row. So you're down here. You're taking -4 minus 2. And your next one, you are going to take 3 minus 7. Okay, your final answer is what that is worked out. So minus a negative is 4. 10 minus 6 is also 4. -4 minus 2 is -6. 3 minus 7 is -4. And this is your final answer. If you can go straight from here to the answer, that's fine. But remember, I grade work, so if you get something wrong, you'll lose more points. This one here, we cannot add. They are not identical. This is a 1 by 3. This is a 3 by 1. You cannot add them. There is no solution. Okay, this one here. I hope you're doing a good job. We're going to take 11 plus negative 8. So 11 plus negative 8 is 3. Let's do this in 2 steps so I know you're okay. 11 plus negative 8. Your next one is negative 3 plus 4. Now you're going to go down to your next row. So you're going to take 5 plus 3, and then 6 plus negative 9. And your next row, you're going to do negative 2 plus 0, and 2 plus 10, because you're adding this time. So then your final answer will be over here, and you're going to have 3, 1, 8, negative 3, negative 2, and 12. Final answer. I hope you did good. All right, now you know your properties, your commutative, identity, associative, all of those. Those also work with matrices. So I can add them in any order and get the same answer. I can add these two first, or the last two first, your associative property, and still work. If I add 0, which is an identity matrix, we'll talk about later, you will get the same matrix back. If I take a matrix plus its inverse, I will get 0. Those are the same as in addition and subtraction. Okay, scalar multiplication just means if there's a number out front, I want to distribute this number to every element inside. So that becomes 15, you're multiplying. 3 times 0 is 0, 3 times negative 2 is negative 6. This one just becomes 3x, this is 12, and this is 9. And that's the final answer until we put equal signs with them. All right, now we're going to put all of this together. This says I want to take 2 times A, so 2 times this matrix. Then I'm going to take that answer and add it to B. So we take 2 times the first matrix, I just wrote it down, plus B, the second matrix. Now we actually do this math. So we get 0, 10, 18, and negative 6, this matrix here. Wrote the second one down. Now I'm just adding them. 0 plus negative 2 is negative 2. 10 plus 4 is 14. 18 plus 1 is 19. Negative 6 plus 6 is 0. Final answer. Okay, pause and try yours. The first one, I just wanted you to take negative 6 times the B matrix. So you're taking negative 6 times negative 1, negative 2, 8, and 5. And you should have gotten 6, 12, negative 48, and negative 30. Final answer. Okay, the last one's a little bit harder. I hope you did a great job on this. If you haven't paused and done it, then do so. So now we're going to take 3 times the A matrix plus 2 times your B matrix. Now you're going to do both of those scalar multiplications and then add those answers together. So now we're going to take the negative 3 through, and we got negative 12, 3, 9, and 0. And then you're going to add that to, now you're going to distribute your 2, negative 2, negative 4, 16, and 10. Your final answers when you combine all of those. So negative 12 plus negative 2, negative 14. 3 plus negative 4, negative 1. 9 plus 16, 25. 0 plus 10 is 10. And that is your final matrix. I hope you did a good job. All right, let's go through things that scalar multiplication does here. So, excuse me, CD times A, so I can multiply the numbers first and then distribute it through, or I can multiply them through individually. Either way works. An identity times a matrix gives you the matrix back. If I have scalar multiplication, I can multiply each matrix by the C and then add them, or add them and multiply by the C. Either way works. The same with A. I can add them first and then distribute, or I can distribute the A through. So in other words, your same properties of math apply. Okay, I want to solve for x. In order to do this, I have to get x by itself. These are the matrices I'm going to use to solve that problem. So first step is you subtract the A. Okay, now I have to divide by the 3, but remember that really means multiplying by 1/3. So to do this, I'm going to take b minus a. So here's b minus a. I'm actually going to do that because that's fairly easy. Negative 10 minus 2 is negative 12. 1 minus a negative 8 is 9. Negative 9 minus 0 is negative 9. 17 minus 4 is 13. Now I'm going to multiply everybody by, should change colors here, 1/3. Negative 12 times 1/3 is negative 4. 9 times 1/3 is 3. Negative 9 times 1/3 is negative 3. Then 13 times 1/3 is just 13/3. It is okay to have fractions in your answers. Same matrices above, but now I want you to solve for x and try yours. So pause and give this a shot. So this time, you should have added the b. And now I got to get rid of the 2, so I'm going to multiply by a half. So it's 1/2 times a plus b this time. So now you're going to use your matrices. So x is going to be equal to 1/2 times, now we're going to take the quantity. Okay, your a is 2, negative 8, 0, and 4, plus b, which is negative 10, 1, negative 9, and 17. Again, I'm going to do the inside first just because I think that's easier than multiplying everything by 1/2 and working with all those fractions. So now it's 1/2, and my matrix I get here is 2 plus a negative 10, which is negative 8. Let's get a different color. Negative 8 plus 1, which is negative 7. 0 plus negative 9 is negative 9. 4 plus 17 is 21. Now I have to take all of these times 1/2. So 1/2 times negative 8 is negative 4. 1/2 times negative 7 is just literally negative 7/2. 1/2 times negative 9 again does not divide, negative 9/2. And 1/2 times 21, 21/2. And you can leave them that way, or you can change them to a decimal. I do not care. Whichever way works best for you. Okay, multiplying. This is what takes a little bit more work. So when you're multiplying, remember when I said you had to learn how to read a problem? That's very important. You must have the same number of columns in the first matrix as rows in the second. You multiply row in the first matrix by the column in the second matrix, position to position, like first to first, second to second, third to third, and then you add the products of the elements together, and that gives you the element of that term. The resulting matrix has the number of rows of the first and the number of columns of the second. All right, let's see if we can make this dude make sense. We need to make this a little bit smaller so I can get that all on here. All right, I'm taking a 2 by 3 times a 3 by 2. The only way that this is possible if this 3 is the same as this number. If those numbers are the same, I can multiply them. If not, I may not. The answer is a 2 by 2, what's left over. So I'm going to have a 2 by 2. So I'm going to draw out 2 rows and 2 columns. Okay, to multiply, I take this first row right here times this first column, and I do it position to position. That means I take this first one times this first one. 1 and 1. Plus, now I'm going to take the second one times the second one. You are not distributing. It's 1 times 1, 2 times 2, and then the third one times the third one. And then you add those up to get your answer. Now I do the same thing here. So this is row 1, column 1. So that's what I'm multiplying. This here is row 1, column 2. So now I'm going to multiply row 1, right here, the same one, times column 2. And again, we do it the same way. First times first, plus second times second, plus third times third. Okay, now this one here, we're moving down. This is row 2, column 1. So that means I am done with this row, and I've moved on to this row. And I do the exact same thing. First times first, second times second, and third times third. So what are you going to do here? This is row 2, column 2. So you're multiplying row 2. So I'm taking row 2, the first one, times the first one here, 1, 2. Plus, now I'm taking the second term times the second term. Plus, I'm taking the third term times the third term. And you add those up. Okay, let's do this with some numbers so it makes some sense. First thing is, can I do it? So this is a 3 by 4 and a 4 by 6. The columns match the rows, so I can do this. I'm going to end up with a 3 by 6. Here, I have 3 and a 2. They do not match. You cannot multiply them. So what would yours be? Yes or no? 3's match. So I'm going to multiply CD, and I'm going to end up with a 4 by 5, which means I'm actually going to have 20 things in that one. That's ridiculous. Okay, here we go. 2 by 3 and a 3 by 2. Does the 3 match the 3? The answer is yes. Okay, this means I'm going to end up with a 2 by 2. So your first step is to actually draw this out so we don't mess up. Okay, now we're going to take row 1 times column 1. So we're taking first times first, 4 times negative 2. Plus second times second, negative 2 times 5. Plus third times third, negative 7 times 3. Now I actually got to do all that math. So that's negative 8, negative 10, negative 21. I am so out of room. And it's down here. I'll just keep going. That equals negative 39. So now we have to do this again. So I have to take row times, now we're going to the second column, because this is row 1, column 2. So it's 4 times 1 plus negative 2 second times second, 2 times 0, plus the third, negative 7 times 2. We are not distributing, right? We got to add all those up. So that's 8 plus 0 minus 14, which gives us that's 4. There we go. Plus 0 minus 14, which gives us negative 10. Okay, let's do the next one. So now we are done with this row. We are down to this row. Same thing. First times first. So 6 times negative 2, which is, I'm going to put it down here, negative 12. Plus 3 times 0, 3 times 5, which is 15, plus 5 times 3, which is 15. So we end up with, let's see, 30 minus 12, 18. Okay, same row, second column, position to position. So 6 times 1 is 6, plus 3 times 0, which is 0, plus 5 times 2, which is 10, giving us 16. And this is our final answer. Okay, pause and do yours. Can we do this? 2 by 2, 2 by 3, we're going to end up with a 2 by 3. Okay, to remember to multiply, it's row times column. And we have to do position to position. So 2 times 5 is 10, plus 3 times 1 is 3. So my first term is 13. Now we do it again, but we have to do it with the next row. Because remember, this is row 1, column 2. And this is row 1, column 3. That tells us what to multiply. So row 1, column 1. That's what we did. Now we're doing row 1, column 2. So now I got to take 2 times 3, which is 6, plus 3 times 2, which is also 6, so this guy is 12. Now we have to take row 1 times column 2. So we're going to take 2 times negative 1, which is negative 2, plus 3 times 4, which is 12, and we get 10. Now we're moving down to the second row, because this is row 2, column 1. So now we're going to take 4 times 5, which is 20, plus 1 times 1, which is 1. So this guy is 21. Now we're doing row 2, column 2. So row 2, column 2. So row 2, 4 times 3, which is 12, plus 1 times 2, which is 2. So this guy is 14. Okay, now you're doing row 2, column 3. So row 2, column 3. We're taking 4 times negative 1, which is negative 4, plus 1 times 4, which is 4, which gives us 0. All right, so your final answer is 13, 12, 10, 21, 14, 0. Last one, if you looked at this, this was a 1 by 3 and a 1 by 2. 3 and 1 do not match. There is no solution. Gotta like that guy, right? Okay, now we're going to do some math here with story problems. Nothing too awful major. So when you look at this, the first thing you do is you take this guy and you make him into a matrix. So he's 110, $1.50, $2.50, $100, $75, $2.25. Now, if we look, this guy is books, this guy is notebooks, and this guy is binders. All right, now remember when we multiply, we do rows to columns. It says above, I should have read, scholarship you decide to pay. You need 5 books, 7 notebooks, and 3 binders. Well, to multiply, we have to do rows times columns, right? So this here has to represent the books, this has to represent the notebooks, this has to represent the binders. So I'm multiplying like to like. So 5, 7, and 3 has to go in this order. So this is a 1 by 3, and this is a 3 by 2, which means I'm going to end up with a 1 by 2. 1 row, 2 columns. Which makes sense. I need one from each store. So this is on-campus bookstore, this is on campus, and this guy's off campus. And we multiply just like before. We take first row times first column. So we are going to take 5 times 110, which is 550, plus. Next, you're going to take 7, second times second, 7 times 150, which is 1050, if I did my calculations right, plus last 3 times 250, which is 750. So on campus, you are going to spend what does that add up to? Hang on, I need my calculator. 550, 560, 50, 567, $568, I think, if I did that right. Okay, next, we have to do the next one. So same row, different column, because now we're on column 2. So you take 5 times 100, which is 500, plus 7 times $1.75, which is $12.25. I'm going to run out of room. Plus the 3 times the $2.25, which is $1.70. No, $6.75. Okay, add these up. 5, that's 12, 25, 18, 19. $519. So according to this, you should shop on the off-campus bookstore to save the most money. Hope you did a good job. Okay, your turn. Let's see how you do with this. First step should have been to write down this in matrix form. Okay, now how much do we want to buy? Milk. I need 2 gallons of milk, so that's milk because he goes to the first guy. 3 pounds of hamburger because that's second, and 1 package of hamburgers. Okay, I've got a 3 by 1. I don't either. I got a 1 by 3 and a 3 by 2, which means I'm going to end up with a 1 by 2. Make sure we give ourselves enough room this time. So again, it's rows by columns. So I'm going to take this first row by this first column. We're going to multiply first times first. So 2 times 279, 558, plus, now you should have done the second one, 3 times 365, which is 1095, plus, last but not least, 1 times $1.70. That's at least an easy one, right? Add that up, and we get $18.23. That's what you're going to spend at store 1. Okay, store 2. Now, same thing, except now we have to multiply by the second column. So we're taking 2 times 255, which is 510, 5.10, plus, we're going to take 3 times 380, which gives us 1140, plus, last but not least, 1 times $1.65. Add all those up, and you get $18.15, if I did my math correctly. Means I should stop at or shop at store B. I will save more money. I hope you did a good job on this. Okay, the last but not least is transformations. Okay, transformations are just what you did in geometry. Okay, so you write your points. Like this here represents X and this represents Y. If I have a triangle, I have 3 points, and all 3 have to be put in here. So this is 0, 0, this is 4, 2, and this is 3, 5. So we put 0, 0, 3, 5, 4, 2. Doesn't matter which order you do it in. Okay, now if I just want to move him, say I want to move 3 units left. Well, that's -3 on the X, so I put -3. 1 unit down, -1 on the Y, and you just add them up. 0 plus -3 is -3. 3 plus -3 is 0. 4 plus -3 is 1. Same on the bottom. 0 plus -1 is -1. 5 plus -1 is 4. 2 plus -1 is 1. And that would be your new triangle. And then you could graph that. You could go -3, -1, 0, 4, 1, 1. And that is that triangle moved. I think he did it with patty paper. If I want to make it larger, I just take the same points and if I'm doubling, I multiply by 2. So I'm going to get 0. 2 times 3 is 6. 2 times 4 is 8. 0, 10, and 4. Now let's graph those. 0, 0, 6, 10. Hopefully I did that right. 4 or 8, 4. About right there. Okay, draw in your new triangle. And if you've done it right, it will follow those same lines because your angles are the same. It just got larger. Kind of cool, right? I think it's kind of cool. Okay, you have 2. Here, whoops, sorry. This is B, and I want to find BA. So this here is going to rotate. This is what's going to happen. So we're going to take 1, 0, 0, -1 times A, which is 0, 0, right here, 4, 3, 4, 2, okay, I am really messing this up. Let's try again. Let's do this other point. 3, 5, that's probably better. 3, 5, 4, 2, does not matter which order we put those in. Okay, this is a 2 by 2. And this is a 2 by 3, so I can multiply them. I will get a 2 by 3, which is what I need. I need 3 points at the end. So we're going to multiply. I need a 2 by 3. Sorry about that interruption. Okay, so we're going to multiply just like before. Rows, and then we didn't do column 1. Well, anything times 0 is 0, so that's not changing. Then I have to do it times column 2. So 1 times 3 is 3, and so it's 3 plus 0, because 0 times 5 is 0, so that's just 3. And then we're going to multiply by the next column. So 1 times 4 is 4, plus the 0 times the 2, again, is 0, so I got 1, 3, and 4. Now we have to do the next guy. So I'm doing 0, negative 1 times everybody. So we're going to take 0 times 0, which is 0, and negative 1 times 0, which is also 0, which gives me 0. Now we have to do it again. 0 times 3 is 0. I could write it up here, yes. Plus negative 1 times the 5 is negative 5, giving me negative 5. And now we're going to do the last column. So we're here. We're going to take 0 times 4, which is 0, plus negative 1 times 2, which is negative 2. Okay, let's graph these things. So now I've got 0, 0, first point, 3, negative 5, second point, and 4, negative 2, last point. Look what happened. Did it rotate counterclockwise? 90 degrees. Kind of cool, right? All right, your turn. We're going to let C equal negative 1, 0, 0, 1. Multiply it by A again. All right, pause and make sure you're doing this to see if you get it. Okay, you're going to take row 1 times column 1. Well, anything times 0 is 0. Okay, second one, we're going to take row 1 times column 2. Well, this time we're going to take negative 1 times 3, which is negative 3. And we're going to add 0 times 5, which is 0. So we just get negative 3. Next one, again, we're going to take negative 1 times 4, which is negative 4, plus, again, 0 times 2 is just 0. So we get negative 4. So now we're moving down to our third one. So now we're going to take this guy. I'm going to take 0 times 0, which is 0, plus 1 times 0, which is still 0. Now let's take 0 times 3, which is 0, plus 1 times 5, which is 5, plus 0 times 4, which is 0, plus 1 times 2, which is 2. Let's graph these. 0, 0, negative 3, 5, negative 4, 2. What did this guy do? If you look, he actually flipped over, or he mirrored over the y-axis. Kind of neat again, right? All right, here's your homework. Good luck. Make sure you post questions if you have any.